We are still looking at char. There's a few cool things left to look at it in char, and one of them is that you can always convert a U8 into one of them. So you can say, for example, just print out you use from. So let's say char from, and any number here that fits into a U8. So and you don't even have to say that it's a U8 because it can figure it out. So this is a U. This is a German and any other language U with a umlaut, and if you try to make it into something larger, it'll say this is an overflow, so it knows that it's a U8. And also, if you say this must be an I8, it's going to tell you down here that it's not implemented for this. This is the only way to do it by using from. Now, of course, what if you want to use a larger number? Then you would use try from, and try from makes sense because if you have a U32, for example, lots of people use U32, and you want to print that out. Let's say U32s can get up to U32 max. It's like 2 billion to 4 billion, I think. So that is obviously these are not all going to have characters associated with them. We don't have that many characters in the world, and so you have to use try from. So just to show an example of how rare it is to have them match up, let's try it. So standard convert try from. There we go. And let's use some random numbers. So bring in the prelude. Whoops. There we go. Okay. That's it. So now we have access to random numbers, and let's say, all right, we would like to random generator. Let's call it a random generator. Equals thread RNG. That's not spelled right. There we go. Thread RNG. And then with this, we are going to we're going to try 40,000 times to get a match. So we'll say for something in 0 to 40,000, and let's see, let bigger character. So we're going to do some try from here. So char try from, and we are going to take this random generator, gen range, which we learned before, and it's going to go from U32 min, which is going to be 0, all the way up to U32 max, which is going to be this 4 billion or so, and then we're going to let's see, dot unwrap. Let's put this on another line. Dot unwrap, or there we go. Are all my brackets right? I think so. So we will have this bigger character, and then we're going to print it out without a new line, bigger character, and just see how many times it has to try before it can succeed at finding a character in this large. Let's see if there's a thing inside there. All these other ones here are errors. What else do we have? Anything? Whoop. So you can see, chances are it's going to fail, and so you don't want to have this unchecked. So you want to do try from, and that'll let you do it. And so let's just give one example of a successful case. So for something let's go 10,000 to 11,000, like that, and let's print out some characters, and let's see what we get. So try from I, and then let's see what language we get here. And it'll be, of course, we need to debug print, and we could unwrap, but that's fine. We can see it from, let's see, for I in, wonder if that'll work. There we go. We are, oh, this is interesting. This is all symbols. So 10,000 characters in, you have all these interesting characters there, and they're all wrapped in OK. So anyway, that is that's how that works, and that's enough chars for now. Let's see the next one. Let's look at some integers again. So these are they're just some interesting functions I wanted to show you with integers, because they sometimes you might have underflow and overflow. For example, if you have a U8 and you want to subtract, and you think you might have something less than 0, then you can use these functions called checked. So there's checked mul, there's checked sub. Let's see if you can guess what this is. Checked add, I think it is, and checked div. So all of these ones will let you safely use functions on unsigned types in particular. So these are quite useful. So let's say we have 200 right here, and then other number equals 200 U8, like that. And so let's say, so let's print out some results of this. So we have let's say some number, and let's do a checked add. So checked add, and what we do is we just put the other number in there, other number, and then let's see what we get there. So that's going to be none. So you can see it overflows the size of the U8. So if you add to it, then it's not going to work. Whereas if you change this to let's change it to a 1, then it's going to give you a sum, and a 201 inside. So you can that's pretty easy. And after that, in the next video, we're going to look at how to implement the add trait for some types that have integers in them.